Okay, here's a problem that came across my desk. This time we are going to solve a system of linear equations in two variables, or a 2x2 system, with the substitution method. Now, both of these equations are given to us in standard form, so it would be ideal to use the elimination method for that. I already have one example video of that, but you do need to know the substitution method, especially for other types of systems. So let's practice using the substitution method on that. All right, I'm going to call this equation number 1 and equation number 2. And the first thing I'm going to do is pick one of the equations and isolate one of the variables. Does not matter which equation I pick, so I'm going to pick equation number 1. I'm going to pick u plus 6y equals 32. And I can isolate either variable. It does not matter which one. I'm going to choose to isolate u because it already has a coefficient of 1. So I'm going to subtract 6y from both sides, moving that term to the right side of the equation. And that's going to give me u equals negative 6y plus 32. Okay, so that's my first step there. I've isolated one of the variables in one of the original equations. So now I have u equals all of this stuff. All of this stuff equals u. U represents the same value as this whole expression. So according to the substitution property of equality, I can substitute these two expressions with each other. What that means is now I can take the other equation, the other original equation, not the one I already used, and I can substitute this entire expression in place of u in that equation. Okay, so the next thing I'm going to do here is I'm going to rewrite down equation number 2, u plus 3y equals 17. And now that I know that u is the same as negative 6y plus 32, I can substitute negative 6y plus 32 in place of u. And that's going to give me the equation negative 6y plus 32 plus 3y equals 17. This equation is this equation with u substituted. So this is going to be my green star equation. What is so important about this equation is that it only has one variable, and that means we can solve it, right? We started with two equations with two variables, each of which separately we cannot solve. But by using the substitution method, we have been able to make one equation with one variable that we can solve. And so now I'm going to solve it. So let's combine like terms. We have negative 6y and positive 3y are like terms. So that's going to make negative 3y. And then we have our plus 32. And then we will subtract 32 from both sides to move our constants to the right. And that's going to give us negative 3y equals, what's that going to be? Negative 15, I think. Yeah, seems like negative 15. And then we're going to divide both sides by negative 3 to cancel out the coefficient. And that's going to give us y equals 5. Now I'm not done yet. I've solved one of my variables. Remember, I have two variables, two equations with two variables. So now the next thing I'm going to do is bring back one of my original equations. Again, it does, oh, hello. I think my light might be overheating. Oh well, let's just keep going. Bring back one of my original equations, does not matter which one. I'll pick number 1 again, so I'm just going to write that down here next to here just so that they'll kind of be next to each other. So that was u plus 6y equals 32. And now that I know y is 5, I can substitute 5 in place of y in that equation. And so that gives me u plus 6 times 5 equals 32. I probably should have written that bit bigger there. So u plus 30 equals 32. And subtract 32. Oh, not 32. Subtract 30. That's why you should be using a pencil at home. Subtract 30 from both sides to move my constants to the right. And I get u equals 2. So now I know y and I know u. What is alphabetical order? Let's see, I'm pretty sure u comes before y. And so there is my solution, my ordered pair. Right, that's a positive 2. Sorry, I kind of messed that up a little bit there too, which is also why you should be using a pencil. All right, so algebraically speaking, these are the two values, 2 and 5 for u and y, that would make both of these equations true at the same time. Geometrically speaking, this makes a line, or graphically speaking, same thing. This makes a line, which is why we call it a linear equation. This makes a line, which is why we call it a linear equation. And these lines will cross each other on the Cartesian coordinate plane at that point right there. If you have a math problem that you would like me to demonstrate, put it in the comments and I will. Hope that helps.